Today, our talk is correction of the errors of Maxwell electromagnetic field theory. This means Maxwell electromagnetic field theory has errors. We need to correct that. All this we will talk is inside this book. This book, we will 500 page. That is my work for 40 years. We can see this book's name is Electromagnetic Wave Theory of Photons. They talk photon are mutual energy flow composed of retarded and advanced wave. So one important thing of this book is talking advanced wave and also mutual energy flow. This is most important things. Okay, let me first give you what is in the error of magnetic field theory and in Maxwell equation. So Maxwell equation should write in another ways. Let me give you this. Maxwell equation has two curve equations. That is equals long t long b minus the two curves equation are current G and long T long D. This is two curve equation of Maxwell equations. What my correction is, that is give here the magnetic field H have a bar on above means average. This means average. A bar means average. So we said if we can use Hall effect to measure magnetic field effect equipment. If we measure along a circle like this, this called average on a loop. This is magnetic field. So we got a magnetic field B. This this is a Hall effect device. So we can use Hall effect device on a loop, got average magnetic field. In magnetic magnetic quasi situation, we have in magnetic quasi situation we have average magnetic field is equal to the magnetic field. In this situation, magnetic field is same. However, in electromagnetic wave situation, this is also, for example, retarded advanced electromagnetic wave. This is the radiation situation. In this case, the magnetic field is different with average magnetic field. So this is not equal. Not equal. In this case, so we see we got so this is the correction of Maxwell equation. This is a corrected Maxwell equation. So Maxwell equation itself is correct. However, the magnetic field inside the Maxwell equation need a new interpretation. This H is not really the magnetic field, but average magnetic field. The people later can read my book to find if it is my talk is correct or not. The whole book is talking about this fact. Okay, let we continue talk about what is the really why I found these problems. The in 1987, I published the mutual energy mutual energy theorem. So mutual energy theorem can be written down This is mutual energy theory. This is published in 1987. Later we found which time domain reciprocity theorem, that is minus this is one which reciprocity. These two theorem is connected with Fourier transform. Connected with Fourier transform. So they can be seen as one theorem, is one exactly same theorem, just this theorem or closed has been published also with Ramsey and also hoops. It's very similar theorem. Hoops is also in the end 1987. Later also has many people independently discovered this theorem. They all call this reciprocity theorem, but only me call it is energy theorem. It's called it is mutual energy theorem. Call it is mutual energy theory means I think this theorem, the two different current 1, current 2, all physics quality. But if it is call it is reciprocity theorem, that means the two current, one is physics, another is virtual. So there has some different with reciprocity and also energy theorem. This is different. And continue in 2017, I found that this mutual energy theory is not only an energy theory, but energy conservation law. Is a energy conservation law. How I found that? If we look a transformer, we look at a transformer. A transformer that perhaps has a primary that has I1 and also has a secondary core. In the secondary core, I will put a load here. And in this case, we can find this is V1 here, is V2. The current I2, this is I1. Perhaps that has this same name term is this way. In this case, there, if it is ideal transform, so this is ideal transform. In this case, the primary will offer a power P1. This has a P1. Here will also has a P2 give to the resistant. Here has a resistant. The input. We perhaps can call this is a transform. This is transform. So this is the input power and should equal to the output power. This is clear in an ideal transform. The input is equal to the output. This is the energy conservation law for transform. Is clear. This is energy conservation law. However, we can make a little bit we know this will give the primary will give here electromotive force. This is from 1 to 2. And also the secondary will give motive force. The motive force has same direction with the current. Here is also direction current. This is the second give to the first or primary. We can use Kirchhoff the voltage law. We will find V1 equal minus plus here we found you can see this direction and the law the direction. So we got V2 okay, so that is clear. Here. We put this result to so this is our energy law, energy conservation law. This can be written as if we talk about the average power, the power is average. In this case, we need to give complex. This means average power. So average power for ideal transform should be equal. We consider this formula and this formula, and then this become consider we use the so we got this formula. This formula can be used the definition. So what is this? This definition is here has so can be writing so now C1 is primary core, C2 is secondary core. So now our energy conservation law, writing down this. This can be also continue to writing down as now we can see this is the energy conservation law. In the same time, it is the mutual energy theorem. So we found the mutual energy theorem is energy conservation law. We found this result. However, we checked, we try use this is in this time we try to use Maxwell equation to derive this energy conservation law. This Oh, we try to do this, but it is not possible. So however, we still can use Maxwell equation to derive the above formula, derive the mutual. Theorem. That means we cannot, from Maxwell equation, to got energy conservation law. However, we still can get a mutual energy theory. What is the difference with energy conservation law and also the mutual energy theory? Let me give you explanations. So this mutual energy theorem or energy conservation law can be written as in time domain. So we can writing it as we can writing it is as so. This is same as that. If one is in Fourier domain, one is in time domain. So in time domain, we do not need the complex conjugate, but we need to give a time integral. This is same. When we writing it is as this form, we found this formula can be extended from 2 to n. In this situation, we can write here as n is correct. So our energy conservation law can be writing down this. From this, we can see if I have a region inside, I have two current. This is J1. This is J2. This means this formula means it is only has connection. G1 gives this a power to J2. J2 takes the power from J1, so only connection with these two. If here has another one, J3, this perhaps has connections with this. And has now something is, for example, here has a current G4 if something in outside. So that means there has no energy go outside. Certainly, if here has a G4, they perhaps build a connection with this. However, in this case, we will include, make a bigger circle, connect all that. So in this case, all the current inside the circle, the energy change is all inside, so nothing go outside. What is wrong with Maxwell theory? Oh, Maxwell's theory is different. The thinker has even counting Maxwell's theory, even only has one antenna. This antenna will radiate energy. The energy is called radiation. So the antenna will give the energy to ether. Afterwards, the electromagnetic wave will transferred from ether to outside. So always has energy go outside. So in Maxwell theory, there always they have a pointing theorem. The gamma, here is this gamma. So is a surface. So for a radiation, this is a Maxwell theory. Always has something because the energy is given to ether, and then electromagnetic wave will transfer in the ether. The energy is inside the ether, and later if here has a receiving antenna, somewhere has a receiving antenna, they will got some energy. However, otherwise the energy is go outside. If here has a star, they will some energy is given to them, but our universe is has a lot of empty place, so energy always go outside the universe. In this case, that means Maxwell theory means always has energy for this, has energy go outside. That makes the energy conservation law is fail. So, but mutual energy theorem still survived. However, energy conservation law in Maxwell theory is not successful survived. However, I think these problems, just use brain to think that, I believe this energy conservation law should correct. If this energy conservation law is correct, the Maxwell theory should be somewhere is wrong. It's clear something wrong, and after a few years search, and later I found the problem is magnetic field, definition of magnetic field. So the problem is this. So average magnetic field is not equal to magnetic field. This is caused the problem. And in Maxwell equation, the H actually is average. In this case, I found so your Maxwell equation you can got H, and this H we can also get this H means magnetic field is equal to first we must think R is retarded magnetic field, because electromagnetic wave has two kinds of wave. One is a retarded wave. If it is a retarded wave, this we talking about a far field. If it is advanced wave, it's far field. So this is a correct effect. This means that for far field is electromagnetic wave, has 90-degree phase difference. The correction is 90-degree phase difference. That means also use Maxwell equation calculated magnetic field actually has 90-degree phase difference. For the near field, N is near field, actually do not need to correct. Oh, retard. For near-field duality, why we make a mistake is also because the near-field, that means also the magnetic quasi-static situation. In that situations, average magnetic field is equal to magnetic field. This is the wrong of magnetic theory. So the Maxwell equation need to make very small corrections. So we should that is I have read the Maxwell equation actually is this to occur Maxwell equation. Correct formula is this. What I should also tell that means Maxwell, the electromagnetic wave calculations something wrong with all normal concepts. This is electric field. This is magnetic field. So the magnetic field is they are in same phase. Magnetic field in the same phase. However, this is Maxwell theory. Accounting Maxwell theory. This is wrong. Oh, it is wrong. The real situation accounting my theory. Oh, this is magnetic field. Mhm. Oh, this is a magnetic field. Oh, here has a phase difference 90 degrees. This is accounting, so I call my theory is mutual energy flow theory. Here is only tell us the Maxwell theory has make a mistake for electromagnetic wave. Actually, for electromagnetic wave, the magnetic field and the electric field has 90 degrees difference in phase. However, Maxwell theory tells us the electromagnetic field, electric field and magnetic field is in same phase. That is wrong. And later, I will also tell, I also has a big discovery that is mutual energy flow theory. Actually, this it is conservation law. Also, this is a law. We can use it as a law. What is this? So this is oh in 2017 found this law. So the law is Oh, this is what this part is. Oh, is defined in the gamma. Oh, oh, okay. So this is the mutual energy flow theorem. This theorem tells us what things. So here you have a transmitting antenna. Here perhaps you have a receiving antenna. The transmitting antenna will send a retarded wave to the receiving antenna. When receiving antenna got the retarded wave, they will send a advanced wave back. Advanced wave, the time t is minus value. Take a minus value. Hence, these two waves can be synchronized. When it is synchronized, they created a mutual energy flow. But the mutual energy flow most is come from here, because here is really synchronized. The line connected with receiving antenna and also the connected with transmitting antenna and receiving. This is mutual energy flow. We can see the mutual energy flow is has the particles property. Here in this place, they look like a particle. Oh, here is also same. However, in the middle, it looks like a wave. So I call the mutual energy flow is photon. Photon Cool. Oh, by the way, this mutual energy flow can be also extended to not only Maxwell equation but also Schrödinger equations. And so the energy conservation law also, when we corrected the magnetic field, this concept also can extend it to quantum mechanicals for Schrödinger equations. So we have who build a full theory. Oh, I will speak about these books. All this concept and also all the things is inside this book. We hope all the people can learn this knowledge from this book. This is correct Maxwell theory and also quantum mechanicals. By the way, my theory is very close to Kramer's theory. Kramer has the quantum mechanical transactional so our theorem is very close to Kramer's TI transactions interpretations of quantum mechanicals. Okay, this is my today's talk. I hope all the people can learn. You can read this, find if my talk is correct or not. Currently, this theory is very new, and I hope I can find all the people give me the information. This is my theory is correct or not. Okay, thank you very much. Thank you all the people to hear my talk. Thank you.